Okay, so thank you for joining me today. I appreciate your interest in Trees Pro and the kinds of things you can do with it. And what we're going to study today is how to deal with a downstream or a secondary decision. And we'll use this model. Hopefully, you can all see, but we'll use this model to illustrate the problem that we're talking about. And you know, it's typical. You have a decision node right here at the beginning, and you're ultimately deciding between these two strategies. However, in this model, I have another decision node here and another decision node down here. And let's just look at that for a second and see what we're talking about. We're talking about, and this is a simple training model, but we're talking about a therapy or a protocol that has two lines of therapy. The first line therapy, which is this decision here between these two first line drugs, and then the second line therapy here that decides, if the first line fails, that decides to do the second line drugs. So your natural, at least my natural impulse, if I didn't know better, would be to put another decision node here to decide between the two options for the second line drug. But that introduces some problems into the analysis. It makes it harder to interpret the results from the model. In fact, in some ways, impossible under certain conditions to do that. So let's first show you, the initial rollback of this model. So if I run rollback on the model, you see it's making a decision on the first therapy to go not with first line of A, but to go with first line B. And then once it chooses first line B, it then also chooses second line C rather than second line A. So rollback does show you the optimal path, which is first line should be B and second line should be C. However, if I don't run rollback, if I instead run rankings, so I'm going to run the analysis rankings report, I only see two strategies. That's not good enough, right? That's not going to give me all of the visibility into the results that I need. And it's going to be further exacerbated when I run sensitivity analysis and I'm only seeing the two primary strategies, being the choice for the first line therapy. So I don't know after I choose strategy first line A whether it chose B or C. I don't know that. And the same thing, I don't know after it chooses B whether it chose A or C. And the reason for that is because a decision has to be made downstream first, and then whichever is best then gets passed to here, and that's all that gets presented under the primary analysis results. And that's not good enough. That's not going to get us what we need. And it's even worse when I run sensitivity analysis. So if I run sensitivity analysis one way, and I'm changing the probability that B resolves the issue, and I run that, and I get results again only for the decision on the first line therapy. So I don't know not only what the second line therapy choice was, but I don't know in here whether it switched from first line to second line or not. Excuse me, chose the second line option and switched. Now, I actually did add some extra payoffs in here to tell me that, so I can see it here, but you wouldn't normally do that. You wouldn't normally say, well, I'm worried about the second line choice. I just did it on purpose to show, wow, actually I did switch between the 0.75 and 0.8 for my variable. I did switch from the second line therapy being 3, which is C, to the second line therapy being 2, which is B. And I wouldn't, if I hadn't added these extra payoffs, I wouldn't have known that. And that's really bad. So not only am I not getting sufficient outputs to see all 4 of my actual true strategies, I could be switching within a strategy, within a sub-strategy, or some strategy within a strategy, and not even know it. Okay, so let's go back to the model for a second. So what I'm saying is there are actually 4 strategies in the model. This is the beginning of strategy 1.1 and 1.2, and this is 1.1 and this is 1.2, right? So this primary decision node strategy actually has 2 strategies buried in it. And the same thing is true for strategy 2. I've got sub-strategies buried in it. And what I really need in order to truly evaluate these options is I need my rankings report, both when I run for my base case results and when I run it for my sensitivity analysis, to reflect all four strategies, because they are the protocols involved in those strategies contain both the first line drug choice and a second line drug choice. So I'm going to show you how to add some elements to this model without recreating entire sets of duplicate model structure to handle this kind of case. Okay, it's a good time to take any questions before we do this. So does anyone have any questions about what I'm covering?
Maybe you're going to answer this, but how is the decision at that second node made? Normally, I'd expect to see a probability there, so I'm not sure how this decision is being made.
Okay, so that's a good question. So the decision at the secondary level is made in the same way that decision at the primary level is, which is actually calculating the expected value of cost effectiveness, average cost per patient, average effectiveness per patient for each of these two, and then calculating net benefits based on the willingness to pay, and saying whichever one has the highest net benefits is going to be the optimal strategy. So let me just run. So if I look at the rankings report again, you see the net benefits for this strategy is higher than, for this one is higher than this one. So this one's the optimal strategy because the ICER is less than 50,000. So if it were a simple model and I just wanted maximum or minimum, that's a little bit easier. But when you're doing a cost effectiveness model, the way it handles that is by calculating the net benefits based on willingness to pay times this minus the cost, willingness to pay times this minus the cost, and then it decides which one has the highest net benefits, and it will choose the second one. It is doing the same thing when I run rollback. It is making that decision and saying, okay, the net benefits here, 36,000, are better than the net benefits here, 32,000. So it is choosing second line C, and then feeding that up as the secondary choice for first line A. But I'm still not seeing the visibility. I want my results here and here to show all four combinations of first line and second line that are already included in this model. Does that cover the question?
Yes, with one, when you showed the tree, the result, if you can go back to the tree.
Sure.
You notice when you go out to the red triangles, the terminal points.
Yes.
Payoffs are exactly the same for both choices. Can they ever be different? And what would it do if they were different? So for example, if it wasn't so clear that it was always superior to go.
Well, they're not really the same. I mean, they're all a little different, right? Here, this outcome's causing $3,000 and you had success. This was 3,000, but you didn't. And this was 4,000 and you had a successful treatment. And here's 4,000 and you didn't. So they're not actually all the same at the endpoints.
Well, but what I guess I'm thinking of is the groups of two are the same in the sense that, it's 3,000 for both terminal points at the top, 4,000 for both terminal points at the bottom. Could it ever be like 3,000 and 5,000?
Oh, it absolutely could. This is a simplified model where the cost of the treatment is the same whether it works or not, but certainly it could be different. Just this simple model, you're giving the same two treatments. If you got to here, right? First line already failed, and then you tried second line let me move this. Second line of B, and it either succeeded or it failed. But we still had to pay for both first line and second line, whether it succeeded or not. So the real difference here is not the $3,000. That's the same. It's what was the likelihood of success? 70%.
Okay. I think I understand it now.
Okay, great. So now what we're going to do is we're going to actually modify this model so that we can get all four combinations, because there really are four strategies in this model, not two. Okay, so let me close this, and I'll close this, and I'll turn off rollback, and now we'll get into the actual building part of what we're going to do. Okay, so the first thing we're going to do is I'm going to add another strategy below this one. So I'm going to double click on this node, and I know it added at the bottom. And actually, in the interest of space, I'm going to collapse this strategy, because we're only going to work on the top strategy, and then we'll just, I'll tell you that we would have done the same thing for that. I'm just going to move it up here. And what I'm essentially doing is I'm saying, I want this to no longer be a combined strategy 1.1 and 1.2, meaning this one and this one. I want this to just be strategy 1.1. where the first line is A and the second line is B. Now I haven't done the work yet, but that's where I'm going. And this one is going to be strategy 1.2. Control enter, enters a space there with first line A, and oh, I did that wrong. And second line C. And what I'm going to do is I'm going to use cloning and variable definitions so that when I'm in this strategy, it always goes here. And when I'm in this strategy, it always goes here. That's where I'm headed. Okay. So now what's my next step is to take this decision node and I'm going to change it into a logic node. So I'm going to right click on this, change the type to a logic node. And with a logic node, you're basically looking for a condition. If this condition is true, then you're going to go this way. If it's false, you're going to go this way. So I haven't done the condition yet, but I'm preparing for that. And then, and my next step is what I don't want is all of this repeated. That's what I want to try to avoid. I want to use this as if it were a decision node, but it's not really. It's functioning as a decision node by splitting it into these two strategies. So rather than recreate everything, now I'm going to do the clones. I'm going to make this a clone master and attach a clone copy here. So I got to select this node, go to the subtree menu, create a clone master, and I'm going to call this strategy 1, or I could have called it first line A, and that would have been fine. And I'm going to attach, so now I have a clone master here. I'm going to attach that clone here, subtree attach clone. There's only one clone, so it did that. And now this strategy is a duplicate of this one, but I don't have to create it. I don't have to build all the structure. Standard cloning that I'm sure many of you have already done before. Now, I also need a mechanism. Now that I have the structure duplicated in via the cloning, synchronized, I now need to use the conditions so that I know that when I'm up here in strategy 1.1, the second line is going to be B. And when I'm using the same structure, but within this context, the second line will be C. And to do that, I need variable definitions, right? So what I'm going to do here is I'm going to define a new variable here, because the variables give you the mechanism or the ability to define the same variable with different values for different parts of the model. So I'm going to right click on this node, define a variable. It's a new variable, and I'm going to call it second line B. Oops, it's over on the other screen. Sorry. Second line B. And at this node, I want it to be equal to 1. So I'm creating a new variable, second line B. And at the selected node, which was my strategy 1.1, I'm going to set that equal to 1. And when I say OK, now I see this second line B variable definition equals to 1. Down here, I want it to be equal to 0. So I'm going to right click, define variable. Now it exists, so it's not a new variable anymore. I want to be defining the same variable, but I'm going to set it at this node as equal to 0, because second line B is not true. At the other node, it was true. At this node, it's not. And I say, OK. And now I have the context, even though it's using the same structure, I have the context set slightly differently. And I can utilize that as my condition and just say I want my condition to be second line B is equal to 1. Now, what have I done? And down here, let me just put the hashtag in. So if this is true, that's fine. If it's not true, you come this way. So what is that going to achieve? That means second line B is true when I set it equal to 1. But it's not. So in this main strategy, this is going to be my second choice, my choice for my second line therapy. But down here where I set it to 0, this is not true. So this is going to be my second choice. And now when I run, oh, and one more thing I want to do is I want to turn on the clone copy so you can see them. Typically, you keep them hidden because you can't edit them anyway. But just in order to illustrate this point, I'm going to go to tree preferences, and within the display settings, this tree editing layout, like it's really about how to edit and display models. I want to show the clone copies. And I'm just going to expand it all the way out. So you see, this is a clone copy. It's all gray. I can't edit here. If I'm double clicking, it doesn't do anything. If I double click up here, I can add a node, and you notice it automatically appears down here because they're synchronized. That's just standard cloning. So I'm going to just delete that node. I just added. And now I can run rollback again. Uh-oh, what did I do? I did something wrong. Let me try rollback again. Okay. And now you see, here's my strategy 1.1, first line A, second line B. And what did it choose? It chose second line B because this was evaluated to a true condition. And nobody went here, right? Which means that this part of the model was ignored, really. I mean, it may have been calculated, but it wasn't used. And so the value here of the 3000 and 0.7 is reflective of the value that came from the second line B results. In contrast, when I'm down here, right, the results here didn't go to second line B, went to second line C because this condition evaluated to false. So everyone went here, and now the value from here, the 3000 to 0.8 success, that got passed upstream to my second strategy. And if I, instead of running rollback, I run rankings, now I'm seeing the two results separately, right? So I didn't have to create a lot of extra structure. I maintained the original structure as it was. The only thing I really did was change the decision node to a logic node, add in the condition here, and define the variable differently here and here for the clone master and the clone copy. And now I've actually separated my results so that I get strategy 1.2, first line A, second line C, and strategy 1.1, first line A, second line B, separately reported in my results, which is what I wanted, what I need in order to evaluate this model effectively. Okay, so I'm handling the downstream decision by making it not really a decision, but handling the all the decisions, meaning both decisions, at the original strategy or protocol level. Okay, any questions on what I did there?
How is that different or better from defining 4 strategies at the root node?
Well, I did define 4 strategies. I mean, I haven't done the bottom one, so just assume. In fact, I'll open up the model that has them both done.
Well, it was looking equivalent to that, and so I was wondering, well, why not just do that in the first place, and then you wouldn't need a logic node?
Well, you could absolutely do that in the first place, but what I didn't want was all this structure repeated, right? Because maybe this is inside a Markov node. Maybe this is buried 6, 7, 8 levels deep, and then there's another 8 levels after that. I don't really want a whole lot of duplicate structure in my model. So I'm using clones to handle it just the way I would for any other time that clones are useful, because ultimately, the more repetition and redundancy you have in the model, the more likely you're going to have errors and inconsistencies. So by doing the cloning, I mean, I am having the 4 strategies, right? What you're saying is absolutely true. But what I didn't want was all this stuff repeated. And again, this is only 7 or 8 nodes, or maybe 10 nodes, but it could have been 500 nodes, right? In a more kind of publication ready model.
That's what I'm probably not seeing, because this is simple enough. I think, I could just.
That's right. But imagine that this happens downstream in a little bit of a Markov model that may be 6 cycles in, and now you have to have 2 Markov models only because of one little thing. That's what you want to avoid. You don't want to have any additional repetition that's not necessary.
Okay.
So it's a very good question, but that's why we did it. So now we have the finished model. Now I'm not going to do the same thing for both. It's exactly the same what we did down here. It's just now it's after first line B, we have a choice of second line A or second line C, and I have a second line A variable defined as either 1 or 0 for this. And at this point, now I have all 4 strategies for reflecting the combinations of first and second line therapies included as primary strategies for the model. And I see them all here. I see that I have at least some dominance in this. And I also can run my sensitivity analysis. I'll use the same variable. And I can see all, oh, I'm only seeing 3. What did I do wrong? Oh, I'm sorry. I used the wrong model. This is the one I wanted. I only did that. That was the one that I was working on. This is the one I wanted. So I want sensitivity analysis. And now I see all 4 strategies, because there really are 4 strategies in this model, despite the fact that originally it looked like there were 2, because the second decisions were downstream. And now I got all my results, and I can see that they change. You know, I can see how all 4 strategies change within that model. And that could be even more important in probabilistic sensitivity analysis, where you just can't look at all the results. There's too many. You're not going to look at 5,000 different results from the model and consider them all separately and try to figure out when you change from one sub-strategy to another. So in essence, what I really did was, let me just close this before I save it. And I'll close all the results and just compare the 2 models. So whenever you want, you can drag a tab to the side and you can see them side by side. And you see in the original one, I had the decision with 2 strategies, and then I had the 2 sub-strategies buried. And in the new one, I have all 4 strategies explicitly from the decision node, but I really didn't create a whole lot of extra structure, because the original structure it remains in place, and I just have a clone copy of it with minor changes to from a decision to a logic node in order to facilitate that. And now my model's flexible, right? I can go in and refine this as much as I need to without worrying about breaking this one. The connection between these is in place and ready to go, and I don't need to worry about every change I make here having to also make it here. Getting back to Louise's point. So anyway, that's what I have for you today. So I'm open to any questions that people might have on this technique. But it's easy to not know, and part of why we brought this up is it's easy to not realize that when you put a decision node away, a second one, you're not going to get full visibility into this choice, and you really should. And it's particularly important in the case of sensitivity analysis, whether that's deterministic or whether that's probabilistic. Any questions?
Oh, Andrew, sorry, it's Brian here.
Hi,
Now,
Brian.
so basically, anytime you have a secondary decision to be made, which is how you actually structure this model, you automatically, in this case, create a logic node.
I mean, that's what I would do. I would say that there's not very many people out there who know
Yeah,
that
because I
you
haven't
can do
actually
that.
tried the logic function before, so this is quite new to me. Yeah.
Yeah, the logic function is the logic nodes are not as complicated as they appear. It's really the equivalent of doing this. If it were a chance node, then it would be the equivalent of if second line therapy is equal to 1, then this probably is 1, otherwise it's 0. So it's the equivalent with a chance node of saying, if this condition is true, in the middle there, let me drag this out. If this condition is true, then this probability is 1, otherwise it's 0. The real fundamental difference, let me just undo. The real fundamental difference between a logic node and a chance node is this is either true or it's not. It's not 50%, 50%, or 40%, 60%. It's everyone goes this way or everyone goes this way in a cohort model. In a patient simulation model, this could be conditions based on the data associated with that patient, and maybe one patient always goes this way and a different patient always goes this way. And unless, like, let's say a tracker changes for that patient, but in a cohort model, it's really it's always a logical expression. So it's never portion of the cohort
Basically,
goes
it's
this way,
not a
portion goes this
it's not a probability we're dealing with here. It's kind of like a
yeah, it's either true or false.
okay.
Right. So
In this case, you're
I-
structuring, you're duplicating it in order to kind of say if it's true, you want that to be presented in the rankings list.
That's right. I'm basically saying I need this and this to be presented separately. So rather than rebuild all of this, right, which isn't that big, but it could be much, much bigger, I just want to do a logic node and set a variable definition. And now I don't have to recreate anything. Everything here is duplicated, and I know that I can treat it as if it were a decision node, one way or the other, even though my analysis will treat them as separate strategies.
Okay.
I see somebody has a hand up. Feel free to speak.
Hi there, it's Mila.
Hi, Mila.
Question, from a just process point of view, does it make sense to do this, set up the logic node at the very, very end and put the clones in after you've laid out all your probabilities and terminal node costs, rather than earlier on when you still may be making a ton of changes to the tree?
It doesn't really matter. It's more a function of, is there really a secondary decision that you're going to have to deal with one way or the other? If you're not sure, then I might not bother doing this stuff yet, because maybe it turns out I don't actually go that direction. But once you're certain that you have that secondary decision, you could do it anytime. And the key there is, you know that they're going to be synchronized.
Right, because you've made the as uncloned,
Right.
which clones don't change.
Exactly. So this changed, then this gets added, and when I delete that, it goes away in both. So you can do it either way. I would, if it were me and I knew that there was that decision was going to be there, and there was nothing that was going to decide that I wasn't going to need it, then I would do it, right away. But it's really not important whether you do it sooner rather than later. What you want to avoid is building out this whole strategy, right, when this one's not done. And I recommend this, not just in this situation, but in basically all models. I think it makes the most sense to build one strategy first and ignore the other strategies, because you're going to be surprised how often what you learn up here can be applied down here. Now, it's not always as clean as just a clone, but that doesn't mean that there aren't elements that you could end up copying down, because that part of the disease progression works the same regardless of the treatment. So I find it most useful or most efficient from a modeling perspective to build out one strategy and get it working before you start building out the others. And I try to focus on the easiest one first, because oftentimes portions of that can be reused as you get to the more complicated strategies.
Right, agreed. Thank you.
Well, we managed to go all the way to 11:30, so that's good. But does anyone have any other questions before we break?
Yeah, I do. Couldn't you achieve the same thing by creating a clone with the first strategy, defining the probabilities at the various subsequent decision nodes by variable names, and then redefining the values of those probabilities just to the left of the first probability node?
I think you probably could, but this was built to illustrate this point, and that won't always.
No, I get it. I'm just trying to see.
But I do agree. I mean, I'd have to think a little bit harder about it, but there's a good chance that you could do that. But rather than the second line, I could do something like that. Just have whatever the second line is, and then have it be. I'd still use the cloning, but instead of having a logic node, I might have a bunch of variable definitions here that say what the cost of the second line therapy is, what the probability of resolution is, and then I wouldn't even need this structure at all. So yes, I do think there's other ways to approach it within this context, but I still wanted to illustrate this point, because ultimately what I'd be worried about is a decision in a Markov node. So let me just open up just an example Markov model. Now imagine that something out here, right, in a model like this, here I have a decision, here I develop resistance to whatever the treatment is. And now I have to choose, second line. That could happen like any time into the future. And maybe you could do it with the variable definitions, but what I absolutely don't want is a decision node here. That's going to really, really make it almost impossible. In fact, we may have blocked that so it won't run. I can't quite remember because I never do it, but you really don't want to have a decision node here that at some point could change. And especially if you have a simulation model where it could be dependent on something that happened to a patient that's stored in a tracker, it's going to get more and more confusing. The bigger and deeper the nodes go, the more complicated the model is, and when that decision is way into the future, like 20 years into the future, let's say. This technique, I think, would be most helpful in that context.
Or you could have maybe 50 time periods in your Markov, and the decision could occur every period.
It could, yes.
Okay, now I'm okay.
Right, so this developing resistance could happen anytime. Right, and right here you could be saying, okay, now I'm on a different. You maybe set some trackers for a patient or something like that, where you develop resistance, and maybe you have to go to different states or something like that.
Yeah.
So there's different ways to do it. You're absolutely right. Some of that could be handled with more complex variable definitions, but this was simpler, because I had the structure here and the structure here, but I just had one variable definition that did it.
Yeah, I can see if the model gets more complicated, this makes more sense. Yeah.
Right. Good questions, though. You're absolutely right. There are different ways to handle that situation. Any other questions? Okay, well, I guess we're done for the day. I want to thank you all for joining me. I will have this recording up probably the beginning of next week. And for anyone that wants to look again, or you want to send this up to a friend, and we will be doing another webinar, soon, maybe a month or two. And thank you again for joining us.
Thank you.
Okay, bye-bye.
Thank you.